the bond parameters? Bond parameters, my dear students, very simple, my dear bachcho. But bond parameters is nothing but bond length, bond order, very simple, very important. Then after that the MOT, then whisper, PSEPR, PSEPR theory. Then after that BBT theory. Then the another important thing is what is the another important thing? The four important, and the another thing we need to discuss about hybridization, very important for your JEE exam. Every time one question is compulsory from this one. Students, according to your NDA, minimum two questions. According to your previous year questions analysis, also minimum two questions are coming from this part, coming from this chapter. My dear students, hybridization, and also the mu value calculation means dipole moment, which is polar, which is non-polar, and other important. Okay, my dear students, let's start. Let's start with that. What is chemical bonding and the types and the operator? Okay, let's start with the basic one. Let's start with the basic one. My dear students, I hope it's clear. I hope it's this points are clear. These points are very important. I waited, and you must should be know about the hydrogen bonding also. Hydrogen bonding also important. Hydrogen bonding. These are the subtopics of a chemical bonding. In this particular class, your Suhas sir going to discuss all this stuff, all these points. Okay, all these points he will be going to discuss. Okay, to puzzle shoot all this thing. Okay, I hope it's clear. Okay, my dear students, let's start. Shall we start? Yes, sir. Let's start. I will start with a chemical bond. Okay, chemical bond. I will give you a beautiful example, my dear students. Friendship bond. For example, just imagine your Suhas sir is best friend for you guys. If he is a best friend for you guys, he will share everything, you will share everything. What it will happen? We have some bond, we have some attraction. We have some attraction. The force of attraction, we both have attraction. For example, you like me, I like you guys. We have an attraction. If we have an attraction, then our bonding is good enough. Similarly, what is bond? Bond means it is an attraction, some attraction between the two elements. What is bond? It is an attraction between two elements, or it will connect the two elements. For example, if you consider A, this A may be positive, may be negative, may be element. Just consider as an element. If this element, my dear students, this is an element, it will attract a B. Then it will hold with some force. Maybe it's a big Van der force is there. Examples we have many force. This force is called as a hydrogen bonding. Sorry, not a bonding. It is a normal chemical bond. What is called as a chemical bond is a force of attraction between two elements. It will held together by some force. It is held together. This is all called as a chemical bond. My dear students, especially in the case of a chemical bond, we broadly classify into hydrogen bond, metallic bond, non-ionic bond, ionic bond, and other things. But actually, we are considered the entire chemical bond to two types. Entire chemical bond to, my dear students, two types. First one is it ionic bond, then the covalent bond, then also we have a hydrogen bond, metallic bond, weak bond, strong bond. Actually, we classify it as weak bond and strong bond, guys. Weak bond and strong bond, and this one. But in your syllabus, these two are important. Why? Because especially the Fuzzen's rule, it deals with covalent character. It deals with covalent character and other. Okay, students, I hope you clear. This thing is not that much important. Now you need to only focusing for a JEE exam on the main important thing. Okay, if you want a complete pure theoretical explanation, is again pure from the basics, guys. You can download the app. It is already there on JEE Crash Course is there in the app. You can subscribe the app and you will get the entire video recording lectures and with the video. And with the video you will get. My dear students, let's start with that. First important one, octet. Octet. We already know sodium. What is the sodium atomic number? Sodium atomic number is 11. 11. We already know in class 9 what topic is there. Valency. Total number of valence electron present in its direction. This sodium, and also we can tell that all atom have one tendency, to get a noble gas configuration. Correct, my dear students? All atoms have a tendency to will get a noble gas configuration, to will attain a noble gas configuration. On that time, this theory is very This one. Chlorine. What is the valence? 7. Now what it will happen? This sodium atom gives you one electron towards the chlorine atom, then it will form a one bond. This bond contains two electrons. This is the actual electronic configuration of Lewis dot structure. We can call it as Lewis dot structure. What is actual Lewis dot structure, my dear students? Very simple. When an electron is there, put the electron or writing a both the element. A both the element will be very clear. Either one will be Lewis dot. I hope it's clear, my dear students. Okay, let's move. Let's move, my dear students. Lewis dot structure. Here. Now, this is the latest approach to chemical bonding. What is every atom has a tendency to complete its already done. H has a tendency to complete its duplet and again other things. Look here. This is water molecule obeys. This H is completely duplet by using the oxygen atom and other things. This order does not obey example. I hope it's clear. Now, this is the type of a bond. I say you know mainly ionic and covalent, but we actually classify it as a strong and weak. Strong means energy more than 200 kg because 200 kg. Very simple. We have one best friend. My best friend is there. For example, just take X. Example as X. X is my best friend. Me and my best friend, the bond is very strong. But sometimes what will happen? Something is happen. On the time we need to break our bond, but our bond is very strong. Then it is example for strong bond. For example, the unknown people. Unknown people in one day we maintain some bus stand and other things, other stations. We can easily break our bond means in the, that is the example. In the case of a strong bond, we have ionic bond. Ionic bond means very simple, guys. One atom completely share or one element share the electron to the other element. To the other element. Other element it will accept. Example NaCl. Similarly, covalent bond, coordinate bond. It especially we already discussing a coordination compounds very important. My dear students, metallic bond, the bond with the metal, hydrogen bond, metal bond force system. This thing is there, guys. Weak bond is there. Now after that, we have a few exceptions. Just imagine Lewis operator it will never get a good one. It will show something, but something, for example, look here, BCl molecule. This is the octet structure. This will show incomplete octet, but it is still stable. Why? Because boron has only 6. According to Lewis structure, according to Lewis structure, or according to octet rule, what is exactly whenever the atom donate or it will accept 10 times 6 electron, my dear students, this thing. And also second one, due to the electron cohesion molecule, compound in the central atom more than 8 electrons. Example is PCl5, SH6 and other things. Then also we have it due to the pseudo inert gas configuration is exception. Then after the cation having an electron between 9 to 17 in their outermost cell. Look here, it will show the 9 more than odd electron molecules. These are the exception. Now my dear students, octet rule is done. Then the second point is, what is the second point? You can tell that's the second point. It is Fuzzle's rule. Okay, my dear students, I will explain the Fuzzle's rule quickly. Then after that, let's move for the hybridization and the tricks to learn hybridization. My dear students, Fuzzle's rule. Okay, what is exactly Fuzzle's rule? Very simple. This rule gives an idea about covalent character, my dear students. What it will give? It will give an idea about covalent character. It will give an idea about covalent. Covalent. What exactly this rule says, students? If the compound, the combination of compound contain, for example, I will write like this cation and the anion compound. If the size of the cation is small cation, large anion, large size, big size anion, it will have a more covalent character. My dear students, it will have a more covalent character means, example, LiCl have a more covalent character than NaCl. Clear? Both are known only, but this is the best example. Similarly, more charge, based on charge, more cationic charge, more anionic charge, more anionic charge, more anionic charge, more covalent character, more covalent character. Which example we can give, my dear students? person should be known about this. This is person rule. Very simple. What is person rule? It will give a highly erotic covalent character, my dear students. If it will contain small cation and the big anion, it will have a more covalent character and the more charge, more anion charge and the pseudo electronic bond. Okay, I hope it's clear. Okay, I hope it's clear. My dear students, now the next thing is hybridization. Before going to the hybridization, I will explain the simple bond parameters. Then after that we have a PPT, then I will explain that one. Okay. Then we already done the update on the bond parameters, my dear students. Before going to that, we can go with the MOT and other diagrams. MOT theory is very MOT theory and the whisper is there. Whisper is very simple. I will explain you guys. Okay. Now let's go for the hybridization. Hybridization means look here. Hybridization means mixing of different shape and octoprominent equal energy atomic orbitals and radiation of energy of a new orbitals of the same shape and the same energy. These new orbitals are called as a hybrid. Very simple guys. Very simple. For example, my dear students, let's take one example. I will take one example. Take two hydrogen molecule, H2 molecule. I will take H2 molecule. Now what I am taking? Hydrogen and another hydrogen molecule. Okay, hydrogen and another hydrogen molecule. Otherwise, you can consider another Cl molecule. Another Cl molecule, hydrogen and Cl. Look here, hydrogen Cl it will form a covalent character. Why? Small cation, large anions, more ionic character HF, HCl, HBr, HF. Which has a more ionic character HF. Why, sir? Small cation, large anion, my dear student. In the case of this hydrogen, which electron present in hydrogen s block, here also we have a sp block element sp. This s orbital overlap with the p orbital like this, my dear students. Then it will form a single bond. This overall this thing is there. Now we can say that CSP hybridization. Hybridization means this suborbit, this p orbit overlap. What it will happen? Overlap, and it will form a new orbit. My dear students. This is what is hybridization. Okay, that is the thing of the one. And also, my dear students, look here. We have a few important points about hybridization. Hybridization is a mixing orbital, the first orbital sigma, and other things. Here, you must also be concentrated on few points here, my dear students. Here, one element can represent many hybridizations depending on the experimental condition. For example, carbon showing sp2 sp3 means depends upon the another molecule also we can show double bond, triple bond, depend upon the value. Then hybrid orbitals difference in sp, sp3, etc. Then this point is important, my dear student. The repulsion between lone pair is more, bond pair is less, lone pair bond pair. This is Westphal theory. Whenever I explain Westphal, I will tell you. Then the different property, different hybrid orbitals. This one. Look here, this is the order sp, sp2, and this one. Okay. I hope it's clear, guys. Look here, this is very important, my dear. My dear, it is very. If it look like AB2, bond pair is to 0, then there is one sp, sp2. Look only in the hybridization and this thing. If it is sp hybridization, it is considered what is the geometry? Linear. Example BeCl2, CO2. If it is sp2, trigonal planar, BCl3, BF3, sp3, tetrahedral, CH4, CCl4. Our main method is there. Our entire smallest hydrocarbon is there here. Then similarly sp3d, sp3d2, sp3d3, pentagonal, square planar, and other things. Here this of few. My dear students, I will show you one important thing. Don't tell this trick for anybody. Don't tell this trick for anybody. I will give one important trick here, and please concentrate this trick. If you know this trick, you will get minimum 4 marks in your exam. There is a perfect hybridization. They will definitely ask you hybridization. Since before learning that hybridization, you must also be know about that one. If it contains coordination number 2, 3, 4, 5, 6. 6 is enough. S means 2 means sp, sp2, sp3 my dear bachcho, then sp3d, sp3 d2. Okay, d. Here, just remove this one. Sp means linear shape, planar, trigonal planar, tetrahedral, trigonal bipyramidal. fail phenom, if the sp3 is there, then sp3d2, what is the sp3d2? Octaedral. Okay, disorder octaedral we have. Like here, my dear students, just you must also know about that one. Now, I will take one example, my dear students. Let's go with the easiest example, CO2. Can I take CO2? So let's go. Suhas sir now give one important trick. Everyone concentrate here. How to find out the hybridization? If you know the steric number, you can easily tell about the hybridization. Steric number is equal to number of atoms. Steric number is equal to number of atoms. Number of atoms plus steric number is equal to, I will tell you again, number of atoms plus lone pair, total number of lone pair, or we can say that as total number of lone pair. Total number of. This is also important for me. What is steric number? Steric number is given by number of atoms plus total number of lone pairs. Okay, my dear students. In this case of the CO2 molecule, how many? Okay, this is the central metal atom, right? Or the central atom, not a metal atom. Sorry, guys. It is a central atom. How many number of atoms attached for this two? Totally, you can say two. Two, right? My dear students, what is valence of carbon? Valence of carbon is over. We already know valence of oxygen is two. Whenever we have a, or whenever oxygen attached with one compound, it must should be formed double bond. It must should be formed double bond. Correct now? Then the meaning is two molecules is there. One molecule form a bond with two electrons or accept two electrons covalent bond, and another molecule form a two electrons. Correct? Any lone pair is remaining? You can say no, sir. There is no lone pair is remaining. Then the answer is two. Two is correct one for sp. Okay, like this. Similarly, let's take another example. Sulfate ion, H2O4 2 minus. Sulfate ion, can you say sulfate ion? Okay, take the formula. How many atoms we have? 4. We have 4, my dear students. One sulfur form a bond with one oxygen means 2 electrons are involved in sulfur valency. Both are same family member. Chalcogen means 4 family members, same family members, sulfur. What is the valence of sulfur? Totally it contains 6 electrons, but here we have it -2 means we need to add 2 electrons. 6 plus 2 is nothing but how much? 8. 6 plus 2 is nothing but how much? 8. 8 is 4 atoms. Any lone pair is there? You can say no, sir, there is no lone pair electron. Then 4. 4 is correspond to sp3. Means it's sulfate ion is a tetrahedral. Then similarly, my dear students, let's take a methane molecule. Let's take a methane CH2. Methane. How many number of atoms we have? 4. But here, hydrogen have a capacity to form a single bond. One electron is there, guys. 1 plus 1 duplex, then 4 hydrogen is there. Valence of a carbon is 4, my dear students. Then it already completely form a bond with the hydrogen. There is no bond or there is no lone pair. That's why the lone pair remaining is 0. Then the 4. 4 is correspond to sp. Then similarly, take HCF2. How many atoms we have? 2. Xenon. What is the valence of xenon? It's a noble element. It is an exceptional case. Whenever I discuss in the program, I will discuss about the xenon. Xenon is a radioactive, not a radio, sorry. Noble element. Noble element means it will contain complete electronic configuration or complete octet group. But still, it has a capacity to form a bond because due to their big size, okay, due to their large size, then xenon oxidation state is equal to 8. Valence is 8. 8 means, my dear students, 8 is there, na? 8 in 8, 2 electrons are busily forming a bond with F2. Then the remainder is 6. 6 means how many pairs? 3 pairs. 2 plus 3 is given by 5. For 5, what is the ionization? sp3d. sp3d1. sp3d1, my dear students. Like this, you need to write. What is the shape of this one? Geometry. Shape is linear. The geometry is singular by pyramidal. It looks like this. Okay. I hope you love this trick. If you love this trick, then let me know in chat section. Okay. I need some art with the chat section. Okay, my dear students. I hope it's clear. My dear students, I hope it's clear. Next, move for the bond parameters. Bond length. What is bond length? The average distance between the two atoms is known as the bond length. Guys, look here. Let's move for the bond length. The factor affecting the bond length. It depends upon the few. First one, electronegativity difference. Okay, electronegativity small bond length. More resonance, bond length is decreased. Okay. Then after the nuclear hybridization, if more percentage of S character, then the bond length is decreases. Similarly, this is the example. You can say this example. Okay, my dear students. Then after that we have a MOT and other. Before moving to the MOT, I will explain the one important thing about your entire bond parameters. Please concentrate. Okay, please concentrate. First important thing, I will write you one order. You must should be going. The bond order. What is bond order? I will explain. The bond order means between two atoms, how many bonds is there? That is what is bond order. It is find out by using a formula Nb minus Nd divided by 2. This actual bond order you can find out by using this formula. Bond order is given by Nb minus Nd divided by 2. This is the another bond parameter, very important bond parameter, my dear students. NB means number of electrons present in bonding orbit. Number of electrons present in bonding orbit. Nd means number of electrons present in anti-bonding orbit. Number of electrons present in anti-bonding orbit. Okay, you need to find out this one by using a MOT. MOT is their idea. After that, you can know about the bond order. Before going to that, I will give the entire idea about this thing, my dear students. So let's look here. Here in the case of the bond order, I will write one order. You must should be knowing about the bond order. The order is bond order is directly proportional to the bond dissociation energy. Bond dissociation energy of the bond. If the bond order is low, you require the extra energy to break the bond. Okay, you require the extra energy to break the bond, and it is directly proportional to the bond strength. Bond strength also increases. Then it is inversely proportional to the bond length. It is inversely proportional to the bond length. This is important. Bond order, bond dissociation energy, bond strength, inversely proportional to the bond length. I hope it's done. I hope it's done, my dear students. This thing is done, bond order is done, then any other important things. Now, my dear bacho, I will give one important trick here. How to find out bond order. Before I will discuss it, MOT, then you will get some idea. That thing is important. Okay, that important thing I will give you. MOT, what is MOT? Molecular orbitals. Okay, look here. Characteristics of molecular orbital. Molecular orbital formed by overlap of atomic orbital, same energy atomic orbital. Number of molecular orbital formed by it is equal to number of atomic orbitals of a overlapping. Half-life sum is the electron configuration in varies or governed by this one Pauli exclusive and students look here this formula. Everyone concentrate. Wave function for a molecular bonding orbital is given by psi A plus psi B. Psi A plus psi B. Similarly, wave function for antibonding psi A minus psi B. Psi A minus psi B means wave function of atom A atom B. If we need to atom, we need to find like this. So let's see here. We have few important things. The difference between BMO and antibonding molecular orbital is important. Bonding orbital means is the result of a linear combination of AO atomic orbital. This is contribution of a linear combination of AO when their wave function of subtracted. If added, you will get a bonding molecular orbit. If subtracted, you will get a antibonding. Certainly, it does not have a nodal plane, but it will have nodal plane is there. Then electron density increases between two nuclei. Electron density, what it will happen, decreases. If antibonding molecular orbital is there, this thing. Okay, now exactly what is molecular wave? Let me know, my dear students. Look here. This is the molecular orbit, shape of the molecular orbit, LCO method. Okay, very simple. How sigma molecular orbital is forming? My dear students, sigma it will form by 2s orbit. What is the shape of the s orbit? It is a spherical shape. 2s orbital forming. If we subtract it, then it will form an antibonding. If you add it, then it will form a bonding. This is the S how it will form. Then similarly, another one, PP overlapping. Guys, PP, it is important. How S and P is forming. My dear students, S and P, if the PP orbital overlap in a horizontal one, not a vertical one, in horizontal. If it overlap in a horizontal, again it will form a S only. Look here, guys, it is this. If you subtract antibonding, if you add bonding. In the case of antibonding, we have a nodal plane, very important. In a bonding, there is no nodal plane. Okay. Then after that, pi electron, it is forming like this. Mind you, it is forming like overhead or sideways overlapping. we can say that more here O2 plus 2 bond order is 3. If more bond order, more stability of the molecule, more stability of the molecule, and also here my dear students in the own second. Okay, my dear students, here we have an important thing about the energy level diagrams. Look here, this is the energy level diagrams of the bond orders. I hope you got some idea about it. Okay, before moving to the MOD, I will explain BBT and other remaining theories. My dear students, what is valence bond theory said? Valence bond theory gives you an idea about the ionization, and another important thing is about the valence bond theory is it will show you, it will give you an idea about which is the most strongest bonding or most strongest attraction. Students, here according to the valence bond theory, you must not be knowing this one. SS overlapping, or if we have a long, if the overlapping is a longer than the stability is 4. Due to this we can write as SS, SP, PP overlapping in the case of the sigma. My dear students, the meaning is PP longer one. ದೊಡ್ಡ ಇರುತ್ತಲ್ಲ, ದೊಡ್ಡ ಇದ್ದಷ್ಟು ಏನಂತ ಹೇಳ್ಬೋದು ನಾವು, we can easily say that as more stronger and more weaker for small one. I hope it's clear. This thing is about the BBT. BBT, that is one important point is there. I already tell you the hybridization by the students. Now, from using entire MOD diagram is now, what is the important thing? You can ask, I will tell you. My dear students, in the case of a MOD, we must and should be know about the electron representation, bonding orbita, ion bonding orbita. This thing we must and should be know. The electronic configuration of that thing is sigma at 1s. This is the order sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz. Then after that pi 2px thus equal to pi 2py. Pi 2px is equal to pi 2py. Then after that sigma star 2pz. Then pi star 2px is equal to pi star 2py. Now, how to check this one? How to check it is correct or not? My dear students, very simple. I will always take oxygen as a reference. Oxygen, one oxygen means 8 electrons to O2 molecule means how many electrons? 16. O2 is a paramagnetic gas. Why? Because it will consist that one electron in the antibody. Now, fill it into electron 2, 4, 6, 8, 10, 12, 14. But here the mistake is there. We can't write a sigma star represent here. If you want, you can. And why I will show you this? Because if you know this state, then you can easily give the answer for the bonding level and the other things. This is the order. Okay, I hope you got that order. Let's write the order. Come, let's write the order. Where is that order? Let's clear it. Look here. Look here. I said now sigma 2pz pi star. Then after pi star sigma star. Very simple. Go with your oxygen, you will get the answer. Okay, my dear. Now, on before that, I already give you one order. I already give you. What is that order? Bond order. Bond order. How to calculate bond order? Bond order is calculated by Nb minus Na divided by 2. Nb minus Na divided by 2. Here is bond order, my dear students. Look here. If you need to fill the water one, for example, He2. I will show you how to calculate for He2. How many electrons is present in the case of He2? 1 helium contains 2 electrons. 2 plus 2 is nothing but 4. If you fill with the MOD, the electronic configuration of MOD, how can you fill that? In sigma 1 is 2 electrons, sigma star 1 is 2 electrons. Now, how many electrons present in the antibody 1? 2. Body 1? 2. 2 minus 2 is nothing but 0 by 2. Anything but 0 is 0 now. That's why whenever they ask the question, helium 2 it will never exist. He2 it will never exist. Why there is no bond? Similarly, my dear student, if you want, you can consider F21. 1 fluorine is nothing but, okay, F2 is an total, okay, 80. Let's fill that one. Okay, F2 means how many fluorine atoms we have? We have a 1 electron in 1 fluorine atom. 9 electron, 9 plus 9, 18. Fill that one. First, we need to start with the sigma 1s. Sigma 1s2, sigma star s 1s2, then sigma 2s2, sigma star 2s2, then sigma 2pz 2, then pi 2px2, pi 2px2, pi 2p by 2, pi 2p by 2. Best I total 2 4 4, 6, 8, 10, 12, 14. Then 5 2px star 2, that's equal to 5 2px star 2. How much is done? 2, 4, 6, 8, 10, 12, 14, 16, 8. This is 8. Okay, now count. How many bond orbits is there in DNA? In the case of a bond, 2, 4, 6, 8, 10, no? 10 is there. Correct or minus 10. Minus 2, 4, 6, 8 is there. 2, 4, 6, 8. 10 minus 8 divided by 2. What is the answer? 10 minus 8 is nothing but 2. 2 by 2 is nothing but 1. What is the bond order between F2, F2, 1, F2? It is 1. But instead of finding all this, I will give you one trick. So it's very simple. First, write down the total number of electrons like this: 11, 13, 14, 15, 16, 17, 18, like this. Then after that, my dear students, I will give you one important thing. 14 molecule, sorry, 14 electron. This is total number of electron. This is total number of electron. My dear students, depends upon the total number of electron, you can easily say the answer. If it will contains 14 electron, then I will present bond order. For example, can we take any example order to prove that one? Which one we can consider N2? N2 means 14. What is the electronic configuration representation according to M14? Sigma 1s 2, sigma 1s star 2, sigma 2s 2, sigma star 2s 2, then sigma 2pz 2, pi 2px, that is equal to pi 2py, both are 2, 2. How many electrons done? 2, 4, 6, 8, 10, 12, 14 is done. Then NP minus ND. Total number of bonding orbitals is there: 2, 4, 6, 8, 10. 10 minus 4 by 2 is nothing but how much? 3. Correct? Done. Then if it contains 13, 15, 2.5. 12 is there 2. 1 is there. 11 is there 1.5. Again 2, 1.5. Okay, this is the C. You must should be remember this one. Very simple. Count the total number of electrons. How much electrons is there in the electron there in the molecule. Then apply this formula, you will get the bond order. And also this formula is very important. Students, if bond order is more, then the bond strength is more. Then it is inversely proportional to the bond. Okay. And also we can say electronegativity is also more. Electronegativity is also more for this case. I hope it's done. I hope bond order you get some idea about the bond order. Now, my dear students, we need to discuss it to another two important things. One is the dipole moment and the hydrogen. My dear bachcho, what is dipole moment? Dipole moment is nothing but, my dear students, mu. Mu is given by charge into density, Q into D, or you can say that mu is equal to charge C into density. You can say like this. This is the dipole moment. Okay, dipole moment. Dipole moment is nothing but distance between this one. For example, in the case of a dipole moment, by using a dipole moment, we classify the molecules into two types. Without those, first one is a polar, and the second one is a non-polar molecule. Polar means whenever the mu value is 0, mu value is not equal to 0, means dipole moment is there. It is what is a polar. If mu is equal to 0, it's a non-polar. Example, you can give a example as a which one is a non-polar one. Yes, we can give a methane molecule, and NH3, NH3 is given for a polar one. Polar means, my dear students, very simple. Methane. Let's get the methane structure. This is the methane. Now, everywhere we have a hydrogen. How much it will extend? This much is also extended. Then everything is cancelled. Then the mu value becomes 0. There is no dipole moment. Instead of this, if I replace one hydrogen with Cl molecule or fluorine molecule, what it will happen? Compared to hydrogen, fluorine exhibiting more charge, dipole moment, more charge, and also it will, the distance is more. That's why what it will happen? This will exhibit a dipole moment. You must also be. Okay. Then after the hydrogen bonding, you already specified the hydrogen bonding in organic chemistry. Hydrogen bonding is nothing but more electronegativity is there. Hydrogen bonding is example for a weak bond. And also van der Waals bonding. Very simple. In the case of a hydrogen bonding, we have a two One is inter-hydrogen bonding, and another one is intra. What is inter? Inter means between two atoms. For example, between two water molecules. Between two water molecules, it is inter. Intra means within a molecule. Within a molecule. For example, within a molecule. Orthomicrophenol, we already know. Compared to para, orthomicrophenol, it shows a very less acidic character due to the hydrogen bonding. NO2 and OH. What it will happen? Like between the molecule, it will show a hydrogen bonding. It is called as intra. Then, but if it shown a between the molecules, it is called as inter. Okay, I hope it's clear. This is about your chemical bonding, my dear student. I hope it's clear. Any points are missing? No, we can say there is no point missing. Now, shall we move for the solving questions? My dear students, I will give you 30 seconds time for each question you need to give an answer. Okay? Shall we start? Yes, students. Let's continue. Let's start with the first question. What is the first question? First question from the JEE 2024 9. The question is the correct increasing order for bond angles among BF3, PF3, CLF3. Have a order. My dear students, this question based on Vesper, Vesper theory, BSc theory, valence repulsion theory. Okay, valence repulsion theory, my dear students, very simple. According to that, lone pair repulsion is more than lone pair bond pair than bond pair. Very simple. I will give it you. You need to give an answer. The answer is very simple. The center atom, the more electron is there. Yavar just electron is there, then it will have a low bond angle. Bond angle is less. I will give you 10 seconds or not a 10 seconds. It is easy one. Take it 20 seconds. Okay, 20 seconds. Give the answer fast. Your time start now. Fast. Yes. I hope it's done. Students, I hope it's done. Now, tell me the answer. CLF3, PF3, BF3. What is the answer? The answer is this one. Option B. Why? Look here, guys. CLF3. Chlorine. What is the total number of electron present in a valence? Sorry, chlorine. The valence electron present in a chlorine atom. Total is 7. 7 means 3 agree with that one. The remaining one is a 4. 4 is 3 in the case of a chlorine. P. Phosphorus. It is a nitrogen family member. Nitrogen, phosphorus. Correct now? 5 is there already. 3, 1 pair is the BF3, there is no electron. That's why lone pair is more. The bond angle is less. That's why the answer is option. Okay, my dear students, very simple. I hope you got the idea. Next question. Number 1. Second one. The incorrect statement regarding ethyl. What is ethyl? We already have a complete idea about ethyl in the case of organic chemistry. C triple bond C. The option is the CC bonds in ethyl shorter than the ethyl. Maybe. Option B, both carbons of sp hybridization. They are asking incorrect. Ethyl is linear. Carbon bonds in ethyl is weaker than the ethene. The answer. I will give you an answer. Very simple, guys. Very simple. Easiest question. In the case of a 9, it will both are at the same shift. Okay, I will shift 1, shift 2. The easy one. Minimum 2 questions, like 2 questions, and plus 1 numerical from this chapter. Minimum. Exactly. 200 question. 200% question. Okay, 200% question. First, tell me the answer first. Tell me the answer. Okay, shall we discuss? Come, let's discuss. What is the answer? Answer now. Here, first one. Ethyl molecule. Ethyl molecule ಅಂದ್ರೆ ಏನು? C2H2 ನ. Let's take as this. ಇದು linear ಇರುತ್ತೆ. sp hybridization. S is the correct one. The CC bond of ethene is shorter than the ethene. S. Why? If bond order is more, bond length is less. Because in the case of ethene, bond order is 2. Ethyl bond order is 3. That's why. What is the bond length? This one bond length 2, 3. Then both carbon is correct, but the CC bond ethane is bigger than no, sir. Bond order is directly proportional to the bond strength. Bond order is directly proportional to the bond strength. That's why the answer is option. Next question. following pairs of electron at the exhibit sp2 hybridization? Both are sp2 hybridization. Tell me the answer in a chart section quick. Tell me the answer in a chart section quick. Tell me the answer in a chart section quick. Fast. Fast. You have 30 seconds, my dear students. Take your 30 seconds and solve it fast. Solve it fast. Okay. So I hope if you take the answer and say D now, no. Let's take it. H2O. H2O we already know it is sp3. Then the answer option is wrong. Again here H2O is there. It is also wrong. BF3. 3 atoms there. 3 atoms there, my dear students. What is the lone pair? There is no lone pair. Boron. It is a hydrogen, helium, lithium, beryllium, boron. sp3, sp2, NO2 minus. 2 atom there. 2 atom with oxygen. Plus any lone pair is there, my dear. Any lone pair is there. Any lone pair is there. Totally 4 lone pairs. No lone pair. Then the answer is wrong. Let's move for here. NH2 minus. Yes, the answer is option. Why? BF3 is sp2 na. BF3 is sp2. sp2, but how can NH2? 2 atoms there. Nitrogen. How many electrons present in a nitrogen center atom? We have a totally 5. 5 plus 1, 6. 6 with that one. No. Total electrons 3 na. 3 plus 1 4. 4 pair one lone pair. From the 3. The answer is option. I hope you got it. I hope you got it. The answer is option. Okay. Shall we move on to the next one? Yes, sir. Krishna. Yes, sir. Krishna. Next question, my dear students. The total number of species from the following in which the unpaired electron is present, which is contained unpaired electron. I will give you this question for your homework, guys. Homework. You need to tell me in which species it will contain. Say unpaired one. Write down as a homework fast. Write down as a homework. Take up. Yes, I hope it's done. Now let's move for the next question. Otherwise, you can give the answers for here only the answers. I am giving it. Now the next question is the shape of carbocation. Students, if you solve the all three values, you can easily analyze as a hybridization. It is a highest weight. Hybridization, one question is common. In hybridization part, one question is common. The next question, carbocation. Carbocation means, for example, you can take as a CH3 plus. This is the carbocation. Okay. Give me the answer first. What is the carbocation? Hybridization. We have a diagonal, pyramidal, trigonal, planar. Give me the answer fast in the chat section fast. Help me fast. Fast. Wake up. Wake up. Okay. How to analyze from here? I already give the number of atoms now. Totally we have a 3 atoms. Hydrogen. How many atoms we have? 3. Means 3. 1 plus means one remove ಮಾಡಬೇಕು. We need to remove 1. Means 0. For a 3 corresponding, what is the hybridization? sp2. sp2 planar answer. What is the answer? Option. Okay. Then move on next question. Yes. One of the easiest question, my dear students. When psi of the wave function, the atomic orbitals, then sigma star. It is nothing but sigma means bonding orbital. Sigma star means anti-bonding orbital. Let me know the answer in the chat section fast. Fast, everyone. Fast. Yes. Very good. What is the answer? Answer is option B. If you add psi A plus psi B, you get a bonding orbit. Psi A minus psi B means anti-bonding. Now, okay. The next question is number of molecules having bond number 2 from the following molecule is C2, O2, Be2, Li2, Ne2, Ne2, H2. What is the answer? Tell me the answer fast. Tell me the answer, my dear students. Fast. You can take your 30 seconds time. Use the formula trick. What I have given over. That one, count the total number of electron. Write down as a 11, 12, 13, 14, 15, 16, 17, 18. 14 electron is a 3 bond order. 15, 2.5, 16, 2, 17, 1.5, 18, 1. Similarly, 13 2.5, 12 to 11 1.5. We need the 12. If it contains 12 or 16 electrons, it has a bond order 2. Now here in the case of C2, 1 carbon 6 plus 6 12 as C2 have a bond order 2. O2 16 16 is there, yes, O2 have a bond order 2. Then Be2 Be2 Li2 Ne2. Now we need to calculate that one. N2 total number of N2 is 14. No, it's not having. Now my question is Be2 Li2 Ne2. How to calculate that? Come on, let's do. 1 B means 10 electrons, sir. 10 electrons. If 10 is there, then 1. Then it is not the Be2, is a wrong answer. Now Li2, why did He2? It is not exist. Why does He2 is not exist? Then Na2. Electron, Ne2, total number of electrons. Hydrogen has lithium and Gandhi, one will be common in nitrogen, oxygen, fluorine, and neon. 10 plus 10, 20. 10 plus 10, 20. 18, 1. 19, again 1.5. 22. 20, how much it will exist? 20, how much it will exist, my dear students? Let me know how much it will exist. No, 20 is not existent to do. How? Why? We can now calculate. From using this C2O2 we get. But we can't confirm the Na2. Okay, Na2 we will confirm by using our normal method. Normal method, my dear students. Na2 means one lithium atom, how many hydrogen has helium, lithium atom? 3 plus 3 is 6. Sigma 1s value is 2. Sigma 1s star is 2. 4. Then sigma 2s is 2. Totally 4 electrons in bonding orbital doing this 4 minus 2 by 2 is nothing but 1. The answer is not right. Na2 is not there. And again Ne2 20 electrons. Sigma 2s, sigma star 2s, sigma 2pz, pi 2px is equal to pi 2py. Okay. Similarly, pi star 2px is equal to pi star 2py. Sigma 2pz star, sigma 2pz star 3, 2, 4, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. 2 plus 4, 4 plus 2, 6, 6 plus 2, 8. This is not a star, normal one. 8 plus 2, 10. 10 electron from here. Minus antibody, how much is there? 2, 4, then 6, 8, again 10. 10 minus 10, 0. Then Ne2 it will not exist. Ne2 is not exist. The answer is not correct one. Then the answer is C2 and O2. How many total number? Only 2. If you get it 2 answer. If you get it 2 as an answer, it is correct, my dear student. If you get it 2 as an answer, it is correct. Next question. Oh my god. Again the same questions all there. The question is, my dear students, the question is, match least 1 and 2. Least 1 is a molecule. Least 2 is a shape. NH3, BRF5, BCl5, CH4 is there. If you want this question, if you want to answer this question before the discussion very simple, we already know CH4 is a which shape tetrahedron. Where D matches to, oh my god, those also NTA also very intelligent students, very intelligent. Look here, all the options contains 2. Then remove this option, my dear students. Okay, solve it from your own, you can get the answer. Ammonia. They ask the shape, guys. They ask the shape. What is the geometry of ammonia is tetrahedron, but not the shape. They are asking shape. Shape is different, geometry is different. Let me know the answer first. Let me know the answer. How ammonia is exactly look like that? Trigonal pyramidal. How? N, H, H, H. Here lone pair is there for a shape. We are not considering a lone pair. That's why the answer is A is 3. Okay. Again we get the 2 options. We will eliminate C. Then BRFI. What is the shape of a BRFI? Obviously square pyramidal. Correct now, square pyramid. The answer is option E. Very simple. Option E is the correct. Okay. Shall we move on next question? Yes. Same type of a question. I need this answer within 30 seconds, guys. They give the sp3, bsp2 ion relation. They give the orientation in shape. Means the geometry one. sp3 sp3d have a regional bipyramidal. Then after that sp3d2 have a octet. Very easiest question. Very easiest question, guys. We'll move on next one. Yes, still let's move. Next question, my dear bachcho. Next question is also same thing. Same thing it is common. Means hybridization of question is. In list one, they give a compound species list to shape or geometry. Shape or geometry. Okay. For this, I will give you one of the easiest one. SF4. SF4 means almost what is the SF4? 4 plus 1 means 5. 5 means sp3 sp3d means signal. What we get? Suhas culture. Okay, let me. They ask the art shape, guys. Tell me the answer first. What is the answer? What is the answer for this question? What is the answer? SF4. It has a Suhas structure. One of the important one. The answer is option A. Option A. My dear students, you can look here. If you check this one, now most of the options contain common one. If most of the options contain common one, then you can easily set the answer. But the fourth one, the BRF, bend shape, T shape. How? BR, F, F, F. This is the shape. T shape is there. Correct now? I hope it's clear. Next, move on the next question. Okay. Number of molecules from the following which can exhibit hydrogen bonding. It is one of the easiest question. It is the organic question. As well as organic but also inorganic. Tell me the answer. Tell me the answer next fast. Fast. Nearest integral you will tell. Okay. Look here guys. Alcohol molecule. I will change the color of the pen. Alcohol molecule. Yes, obviously it will exhibit that one. It is exhibit inter or intra. It is exhibit inter between two atoms. Again, water exhibit. Then this molecule exhibit. Obviously, HF exhibit. Then NH3 ammonia. But these two molecules not exhibit. 1, 2, 3, 4, 5. What is the answer? 5. The answer is. What is the answer, my dear students? 5. I hope it's 5. Then we move on next question. Yes, sir, we can move. Again, the same thing, guys. Match the list with the geometry. Okay. Here we can easily say ICL. ICL means linear shape. A is 4. Okay, you can easily eliminate these two and then the answer. Fast. Tell me the answer in the chat section. You have a 30-second time. Fast. Fast students. What is the answer? You answer is very simple. A is a linear one. Then after that B it have a T shape. ICL3 we already discussed that one. Same as the CLBr, BrCl3. This is the shape of a molecule. Then the CL5 have a pyramidal shape. IF7 is a pentagonal bipyramidal. Okay, these are the answer. That's why the answer is option B. Okay, same question. If you see here, everywhere hybridization of question is covered. Next, oh my god, now it is come for the accession relation. My dear students, accession relation question is one of the important thing. It is also in the step 2 in AP5. The question is, given below we have two statements. One is labeled as accession and another labeled as reason. Accession. Ammonia and NH3 molecule have pyramidal shape with a lone pair of electrons on nitrogen atom. Thus, the resultant dipole moment NH3 is greater than NF. Okay. Reason. In NH3, the orbital dipole due to the lone pair in the same direction as the resultant dipole moment NH. F is the most electronegative element. In the light of the above statement, choose the correct answer. Option 4 we have. First option both A and R true. R is the correct explanation of A. B A is false, R is true. Then we have another two option. Let me know the answer first, guys. Let me know the answer. One of the easiest question. Let me know the answer. So that's very simple. The assertion is correct. Okay, I will explain here, guys. Obviously, the exception in the case of a dipole moment is NH3 have more dipole moment than the NH3. Both are correct. Why? Ammonia exhibit dipole moment due to the presence of lone pair. Here, my dear students, this and this one both are moving at the same direction. But NF3, it is the same charge. Remember now? That's why this is the answer. That's why the answer. Both accession reason is correct. Reason is the correct explanation. Okay, I hope it's clear. NH3 and NF3, why? Because nitrogen, the movement is more. Nitrogen, fluorine, they already give the electron Calculate fast. Calculate fast, my dear students. You can calculate easily. Actually, you can remove. Then CO2. Okay, calculate fast. How many atoms we have? Fast. Fast. Here, ammonia is there. Therefore, HF is there. Then methane is not there. BF3 is not there. Chloroform is there. Yes. SiO4, no. Water is there. 4. BF2, BF2 is there or not? Tell me the answer, total answer, how much we will get? We will get totally, if you give an answer as a 6 is the correct. 6 is the correct. 6 is the correct answer. 6 is the correct answer. Which of those? HF1, H2 is 2, then ammonia 3, BF3 is null 2, chloroform IU, then water. Next question. The correct statement about hydrogen bonding law. Okay, let's discuss the correct statement. We need to choose that. Hydrogen bonding exists when hydrogen is covalently bonded to the highly electronegative atom as A is correct. Every option A is there. Just imagine the thing how the NDA people are doing. Hydrogen everywhere. Option A is the B. Intermolecular hydrogen bonding present in orthomitosis. Inter is there. No, B is not correct. Why? It is there intra. Which hydrogen bonding is there? Intra is there. Option C. Intramolecular hydrogen bonding is there in HF. Now guys, this is the intra is there in inter is there in HF. Intra is there in orthomitosis. Then the magnitude of hydrogen bonding depends as obviously. Hydrogen bonding powerful effect on the structure and the properties of a compound. The answer is option. Very simple. Okay, you can easily pick up. Next, we move to the next question, guys. Yes. The number of species from the following that have a pyramidal geometry around the center. That is sulfate ion combination is there. Tell me the answer. I will give you 30 seconds. Your time starts now. Fast. Fast. What is the answer? What is the answer, my dear students? They are asking about the pyramidal geometry, na? The answer is option B. Answer is option B. Option B is correct. Okay, next one. The number of compound species having a non-zero dipole moment, guys. Again the same question. Is there. Solve it. Meaning as a woman, here very simple. B is here to no. NF is there. NF it will exhibit. Then the answer. How many compounds exhibit first? Tell me the non-zero dipole moment they are asking. Non-zero dipole moment, guys. B is here to exhibit. Here, which one is not exhibit that one? Only CO2 molecule, except CO2 all of, no, only H2 molecule correct now. That's why the answer is 1.